In this video, I would like to explain about some of the network terminologies that we use in the electrical network. So, before getting into the actual topic, let us understand what a network is. Okay, network is nothing but a interconnection of the electrical elements. So, it is an interconnection of the electrical elements. Drawing a simple network here, E R1 and R2. So, network doesn't have to be a closed path or the closed loop. Whereas, if you listen to the term called circuit. This is also most oftenly used, right? The difference between network and the circuit is that circuit is a part of the network which provides the closed path or the written path for the current, which means circuit is nothing but a closed loop or the closed network. So, all the networks that you see cannot be the circuits, but all the circuits are the networks. Okay? Only difference is between the closed path that the circuit provide and a network. So I guess it would be clear. Or we can also say that electrical network is nothing but a combination of active and passive elements. We'll get into further details like what is an active element and passive element. So next we will discuss the active element. So as a name itself suggests that active element is nothing but a part of the network which actively supplies the energy to the rest of the circuit. So it is nothing but active element is nothing but a source of energy in the electrical network. Here if we consider this energy source is a voltage source here, it is supplying energy to the rest of the circuit. So active element is the source of energy which actively supplies energy to the rest of the circuit. And coming to the next term that we use, that is the passive element. So passive element are the ones which consumes the energy in the network or the circuit. They consume the energy in the circuit, which means active elements are the source of energy, whereas passive elements are the ones which consume the energy. We have different passive elements. Okay, coming to the first one, that is the resistor. This resistor, it consumes the energy in the circuit and it converts that energy that it consumed into the heat. And the other passive element is the inductor. So inductor is the one which consumes the energy and stores it in the form of the magnetic field. And the other passive element is the capacitor. Capacitor also consumes the energy and it stores it in the form of the electric field. Okay? Yes. Now coming to the another common term that you listen in the networks, that is the node. So to understand these terms, further terms in a better way, let me draw a circuit here quickly, which helps us for the better understanding. Yes, now we have the circuit drawn over here, and we'll use this circuit for the explanation of the other terms. So as I was telling what a node is nothing but a point or the connection point or the equipotential surface where two or more circuit elements are joined together. So node is nothing but a point where two or more circuit elements are joined together. It is a equipotential surface. Okay, and the next term that you frequently listen to is the junction. Junction is little similar to the node, but this is a combination of three or more circuit elements, whereas node is two or more and junction is three or more circuit elements. So if you consider this point B, it is a combination or a interconnection point where three circuit elements are joined together. As we also listen to this word more frequently in our daily life, junction is a point where three or more roads join, right? So you can remember in the similar way, junction is nothing but three elements joined together or even more. So that is how the basic difference is. Now if you want to understand the same from the circuit you see here, nodes, the all the nodes that you see here are A, B, C, and D. All these are the nodes. Coming to the junction, what are the junction points that we have? B and D are the junction points that we have. B and D are the junction points because they have three elements joined together. I guess it is clear for you now. And the next term that we would like to discuss is the branch. Branch is nothing but a part of the circuit which lies between the two junctions. So remember that branch is a part of the network which lies between two junctions. Okay, and so if you consider this circuit, what are the junctions point that we have? B and D, right? And the branches that we have are BD is one branch which consists of R2, and the other branch is BAD. Okay, BAD is the another branch which has R1 and E1 elements, and the other branch that we have between B and D junctions are the BCD branch which has the elements R3 and E2. Okay, so remember that it is the part of the network which is between two junctions, not between two nodes or a junction and a node like that. So if you consider A and B, A is a node and B is a junction, R1 cannot be the branch because it is between a node and a junction. Similarly, R3 can't be a branch. Here R2 and BAD, BCD are the branches in this example. Now coming to the another common term that we listen to is the loop. Okay, loop. What a loop actually is, it is nothing but a closed path of the network. So loop is any closed path of the network that you see is called a is the loop. Okay, so if you consider this example, what are the loops that we have here? The first loop that you see here is the A, B, D, and A. Okay, and the other loop that you see is B, C, D, B. Always remember you have to close the circuit. It is a closed path, right? So you have to close the circuit. If you start from A, B, D, and A, again from B, B, C, D, and B, close the circuit. And the is the bigger loop that you see is the A, B, C, D, A. So this is the another bigger loop that you see. This one, A, B, C, D, and A. Okay. Now, the another most common term that you listen to in the electrical networks is the mesh. So, what is the difference between the mesh and a loop? A mesh is the most elementary form of the loop. Okay, most elementary form of the loop, and mesh cannot be further divided into mesh can't be divided into further loops. Okay, mesh can be divided into further loops, which means if you consider this example or this loop a b c d and a b c d and a, that can be further divided into these two loops, right? It can be divided into a b d a and b c d b. Okay, but mesh is not the one. A mesh cannot be the one which can be further divided. So from the above examples which are listed, this is not the mesh. ABCDA is not the mesh, whereas ABDA and BCDB, these are the meshes. Okay, I guess it is clear now. Now all the meshes can be the loops, but all loops are not the meshes. Okay, I'll also write down here that what are the meshes that we have from the above example. ABDA is one of the mesh, and BCDB is the another mesh. Okay. Yes, and also similarly nodes and junctions. All nodes, all nodes cannot be the junctions, but all junctions are the nodes. Okay? Yeah. These are some of the basic terminology that we use in the electrical networks. I hope you find this video helpful and all the topics that you uh, learned from here would be helpful in the analysis of any other further electrical networks. Thank you for watching this video.